Today we will discuss about the CBSE sample paper questions of class 12th, and these are MCQ based questions. So we have already discussed in previous video question number 1 to 10, and now this is a next part of the video. So question number 11. For the linear programming problem, the objective function z is equal to 4x plus 3y and the feasible region determined by the set of the constraints is shown in the graph. Which of the following statement is true? A, B, and C, and D. The four options are given. Maximum value of Z is at point this, maximum value of Z at point Q, and the value of Z at R is less than the value at P this, and the value of Z at Q this is less than the value of R this. So we will solve this problem solution. For this solution we have to put one by one all the coordinates which are given in this diagram. This is a P, and this is a O point, and this is a R, and this is a Q point Q. So one by one, Z is equal to 4x plus 3y. So suppose at point P, for at point P, so this will become 4 multiply 0 plus 3 into 40. So this is 120. And similarly this for at point 0 comma 0, so this will become 0 at point O. And now for at point R, Z is equal to 4 multiply 40 plus 3 multiply 0, so this is 160. This is for at point R, and after that, same as it is, this value Z is equal to at point Q. So 4 multiply 30 plus 3 multiply 20, so this is 120 plus 60. So this is Z is equal to 180. This is a maximum value. Maximum value at point Q, and point Q is 30 comma 20. So for this maximum value of Z at point this. So basically this is a solution of this question, and behalf of this solution we let us understand which one will be the correct option for this question. So option number B, maximum value Z is at Q. So you can easily find out this. This is a correct option for this question. So this is a solution. You can easily do it in 2 or 3 values. You have to put 2 or 3 values and you can easily calculate. And for tips, you can also calculate directly without solution this question and find the mm, correct option for this one. And now the second question is question number this: integration of dx over x raised to the power 3 1 plus x raised to the power 4 by square root or 1 by 2 is equal to. So for this question, first of all, we can same this equation like that: dx is equal to x raised to the power 3 x raised to the power 4 plus 1. Of course we can write this, and this we can easily write like that: dx over if now I just want to take common x raised to the power 4, so due to this power it come out x square, so this will become like that 1 over x raised to the power 4 power 1 by 1 by 2 power mean square root, 1 by 2 mean square root. So now this same question will become dx over x raised to the power 5 1 plus 1 over x raised to the power 4 power 1 by 2. Now let 1 plus 1 x raised to the power 4 is equal to 2. When we differentiate this, differentiate with respect to x, so this will become 0 plus, we can write like that, this is same equation 1 plus x raised to the power minus 4 is equal to t. When we differentiate this equation, so it will become minus 4 x raised to the power minus 5 dx is equal to dt. So, and this will become 1 over x raised to the power 5 dx is equal to minus 1 by 4 dt. Now, we can integrate this same question, so this will become, in place d we just put minus 1 by 4 dt and e raised to the power 1. Basically, this is a question. Now integrate this one. Dt. So this is minus 1 by 4 and e power minus 1 by 2 plus 1, and same as it is minus 1 by 2 plus 1 plus c. This is the integration. So minus 1 by 4 t raised to the power 1 by 2 over 1 by 2. So this is minus 1 by 4 and 2t raised to the power 1 by 2. It will become minus 1 by 2 square root t plus c. So when we substitute the value of t, so the value of t is 1 plus 1 by x raised to the power this one. If we solve this, so square root x raised to the power 4 plus 1 over x square plus c. So this is minus 1 by 2x square and square root x raised to the power 4 plus 1 plus c. So we just match the option which one. So option number A is correct. And this same equation we can also write like that. This part we can also write like that, minus 1 by 2x square root 1 plus x 4 plus c. So this is option A. Option A is the correct one. So this is a solution of this question. And now after that, let us understand the question number 13. So integration 0 to 2 pi cosec 7x dx will be, which one is a correct option? So we know that the property 0 to 2a fx dx is equal to 0 if f of 2a minus x is equal to minus f of x. So let us check this property. So let f of x is equal to cos x 7x dx. So for this f 2 pi minus x is equal to cos x 2 pi minus x. So this is in the fourth coordinate a s t c. C mean cos x will be negative. So minus cosec x. So this is actually minus f of x and f of 2 pi minus x. So this property, when this is possible, so the value of this question will be 0. So option number A is a correct option. So we can put this same as it is equal to 0. So this will be the option number A. Now let us understand the next question. The question number 14. What is the general solution of the differential equation this? So e raised to the power y dash is equal to x. So for this we can write this equation e raised to the power dy by dx is equal to x. Because of that y dash is equal to dy by dx. Now this equation we can write like that dy by dx is equal to e raised to the power x. So this we can write like that dy is equal to e raised to the power x dx. This is a main equation. We can integrate by integrating this equation. So this equation is equal to dy is equal to integration e to the power x dx. So we can write this equation like that. Not here we can write log x. So log x, this will be the log x. So this equation we can write dy is equal to log x and dx. Now by integrating, so dy is equal to integration of log x dx. This is a question and this is a part 1. So we all know the integration of a log x. This is a y is equal to x log x minus x plus c. So if you don't know the integration of log x, you just find the integration of log x 1 to log x dx. So with the help of product formula and product of integration, you just find the integration of this one. So you can find this. So you all know how can we solve. This is a first part and this is a second part. So log x as it is integration of 1 dx minus integration differentiation of log x into integration of 1 dx and now dx. So log x into x minus integration 1 upon x into x dx. This cancel out, so x log x minus x plus c. So basically this is the why for this question. We can match the option for this question. So option number, I think so, this is option number B is a correct option. Now let us understand the question number 15. So basically this is a 1. So the domain of this diagram will be, according to this diagram, so the domain will be -1 or 1. So if domain is -1, so option number B. So this graph actually cos inverse x. All the range in domain are following according to this, because of the this graph cut pi by 2, and the range will be 0 to pi, so that option number B will be the correct option. If you know all the graph of trigonometric function, so you can easily identify within a second which one will be the correct answer. Now question number 16. The linear programming problems along with the graph of its constraints is shown below. The corresponding objective function z is equal to this, which has to be minimized. The smallest value of the objective function z is 134, and it's obtained at the correct option 3, 8. So the optimal solution of the above linear programming problem is does not exist, as the feasible region is unbounded. Option number B does not exist as inequality, as the inequality this does not have any point in the common with the feasible region and exist. So number C, this is infinitely many point and exist as the inequality this less than 134 does not have any point in common with the feasible region. So basically this is also the question of linear programming, and talk about this coordinate 3, 8. So in this coordinate we had to check the value of this. So z is equal to 18x plus 10y. So z is equal to 18 multiply 3 and plus 10 multiply with 8. So z is equal to 54 plus 80. So z is equal to 134. So basically this is the value of z. So at this region, and now if this point is a point P, so in this point this line, this dotted line represented this region, and the so the property of linear programming, we can understand how we can resolve this problem like that. Because of that, the minimum value of in this point, because of that this shaded region in this side, so the minimum point this will be feasible for 134. So in this question, objective function this which has minimize has to be minimized, and the smallest value of objective function is this. So actually smallest value is this. So option number D, because of exist as the inequality this less than 134 does not have any point in common with the feasible reason. So this is a correct option for this one. And now after